Climate change is a relatively new topic in water utility risk management. On the other hand, it's being considered in long-term water supply reliability planning by larger water agencies. Some lessons have been learned in this arena and will be shared in this module. Keely Brooks with the Southern Nevada Water Authority will provide some real-world examples of how SNWA is considering its changing risks due to weather and climate and how it's working to prepare for the future.
The Southern Nevada Water Authority is a wholesale water provider to 2.2 million people in Southern Nevada and more than 40 million visitors annually. 90% of our water supply comes from the Colorado River, so our community is particularly vulnerable when stream flow in the river remains below average for multiple years. And this is just what we're experiencing today. The basin is currently in a record drought, which before the 2000s was not thought possible based on stream flow records covering most of the 20th century. Water managers now recognize assumptions based on recent hydrology don't fully capture what could happen in the future. How are we understanding and assessing changing drought characteristics and other risks from climate and weather? Southern Nevada and the other basin states that share the river partnered with the Bureau of Reclamation, which manages and operates the Colorado River, to fund a joint study released in 2012 to look at the range of potential supply and demand scenarios and compare the different outcomes. One of the supply scenarios used hydrologies developed using global climate model projections instead of assuming past hydrology. The study estimated that stream flow could decrease by nearly 10% over the next 50 years from climate change alone. The implication is that the risk of drought in the future is increasing. Shifting gears now to the local assessments, we're exploring what the changing risk and from weather and climate will mean to our infrastructure, pipes, pumps, treatment, and electrical facilities. Once again, the first step was to look at what the climate models projected for our region. We worked with climate scientists from the California-Nevada Regional Integrated Sciences and Assessment, a program partially funded by the National Oceanic and Atmospheric Administration, to better understand the potential conditions we may experience. We're currently conducting an internal evaluation to assess what risks are sensitive to weather and climate to inform our agency's key decision-making processes, such as asset management, capital improvement, and the health of our workforce. This leads to our next topic. How do we incorporate increasing risks from climate and weather into our decisions, recognizing that supply availability may be changing in the Colorado River Basin? SNWA has taken a scenario-based approach to water resource planning for our community. This approach helps us think outside of current circumstances and historic operations so we can create contingencies for different outcomes. Specifically, if stream flow continues to remain below normal, Nevada faces reductions in its annual water allocation. We look at different what-if supply and demand scenarios to see how soon we may require additional water supply options. Fortunately, the demand management practices and conservation programming we employ help reduce water use and push the need for new water supplies further out into the future. For SNWA, the risk of drought increasing in the Colorado River Basin means a higher risk that Lake Mead's water level will decline. And this presents challenges beyond the risk of reduced supply availability. Declining lake levels puts SNWA's ability to access our main water supply at risk, and it presents water quality challenges. When reservoirs are full, our water intakes and pumping stations at Lake Mead work as designed, and we can access our water resources. As the surface of Lake Mead declines and approaches the elevation of our pumping stations, pumping capabilities become less efficient. If the surface of the lake drops below 1,000 feet, our two existing pumping stations will be unable to access these supplies. Declining lake levels also impact water quality. As the elevation continues to drop, warmer surface water approaches the intakes and pumping stations. Warmer surface water in general can be poorer in quality than deeper, cooler water. Additional treatment is needed, which can be costly. How has looking at different future scenarios influenced decisions for our utility? In 2014, a Citizens Advisory Committee recommended the SNWA build a low lake level pumping station to protect the community from losing access to nearly all of its water supply due to declining lake levels. The advisory group learned about the risk factors associated with declining lake levels, as well as the additional risk factors posed by climate change. The advisory group recommended that our agency move forward on constructing a new low lake level pumping station to ensure continued access to our water supplies in Lake Mead. Construction of that facility is scheduled for completion in 2020. Are low lake mead elevations a new normal? Well, we aren't sure, but we are preparing for that possibility. We're investing $58 million to refurbish the filtration beds at one of our water treatment facilities because we assume low lake level elevations will be more common in the future. We went a step further and considered climate projection information to ensure the filtration bed heights and media were appropriate given anticipated water levels and temperatures. These are just a few examples of how SNWA's risks from climate and weather are expected to increase and how this influences the research we fund, our long-term planning approaches, and the infrastructure investments we're making to reduce these risks.
Next, Lorna Cates will provide examples of Denver Water's climate adaptation assessment and planning.
Denver Water is the largest water utility in the state of Colorado. The majority of our supply comes from high elevation Rocky Mountain snowpack. Denver Water serves high quality, reliable, and safe drinking water to a quarter of Coloradans and is actively working to ensure we are prepared to meet customer needs today and continuously into the future. As we have learned from Keely Brooks in the previous module, climate change is a risk enhancer and threat multiplier. Denver Water experienced this firsthand in 2002 when unprecedented simultaneous natural disasters caused by extreme weather took place in our watersheds. First, Colorado experienced the single worst drought year in the state's recorded history. In the summer of that same year, the largest wildfire our state has ever experienced broke out in our largest and hardest working watersheds. Just weeks after the fire was contained, a rainstorm brought sedimentation and debris into our streams and reservoirs, significantly impacting water quality and reservoir capacity. Now, 16 years later, the watershed is still noticeably scarred. While climate change did not cause these disasters, the science tells us that recent warming contributed to their impacts. Denver Water understands the importance of addressing this challenge and is actively working to understand and prepare for changes that may dramatically impact our system, such as continued warming and extreme heat, intensified droughts, floods, and forest fires, and changes in our high elevation source of supply, snowpack. I will describe our approach with the following 3 points. 2002 presented Denver Water with an opportunity to reflect on our assumptions and the way we analyze our system and plan for the future. For example, we used the observed hydrologic record to represent future hydrologic conditions. One question was, is this the best approach and does it sufficiently set us up to prepare for the variability our region could experience? To answer this question, we needed to understand what our region had experienced before we started making observation. We did this by developing paleohydrology, a technique that uses tree rings from old trees to reconstruct past hydrology. Now we have data going back to 1634, and we found droughts in the 1600s and 1800s that are much worse than 2002, and much worse than our multi-year planning drought in the 1950s. Paleohydrology broadened Denver Water's understanding of the hydrologic variability our region has experienced in the past. We also have a better understanding of what that variability means to meeting our customers' needs. Next, we wanted to understand what else the region could experience in the future, so we turned to climate models to explore possible future conditions. Since the rivers that feed our water systems are shared with other utilities across Colorado's Front Range, we invited 5 other water utilities, the state of Colorado, the Western Water Assessment, the National Center for Atmospheric Research, Research Triangle International, and the Water Research Foundation to engage in a climate assessment. We called it the Joint Front Range Climate Change Vulnerability Study. Together, we explored potential future hydrology and developed a thorough understanding of climate models, projections, climate assessment, and uncertainty. I want to focus in our lessons in uncertainty because these are what have informed Denver Water's climate adaptation philosophy. It also has informed our long-range planning efforts. As you can see on the scatter plot slide from the Front Range study, there is a wide range of ways climate may change in the future. Along the x-axis are changes in temperature, and the y-axis are percent changes in precipitation. Both compare past periods to future projections, centered around the years 2040 and 2070. What we learned from the scatter plot is that our region will continue to warm as greenhouse gases increase in the atmosphere. The exact amount our watersheds will warm over time is completely uncertain. We also learned that precipitation in our region may increase, as indicated by all the dots above the red line, or it may decrease, shown by all the dots below the red line. there is not a consistent signal of how precipitation may change in our region. The Front Range study went on to evaluate the impacts of streamflow due to 10 of these projections: warm and wet, warm and dry, hot and wet, hot and dry, and a middle-of-the-road scenario for the year 2040 and 2070. But it was the scatter plot findings that most influenced Denver Water's next steps in climate assessment. We learned that modeling precipitation is incredibly complicated, that our region may not see model agreement for precipitation, and that there is more skill and confidence in temperature projections. So, Denver Water shifted our focus to warming. We completed a simple assessment to examine the impacts of 5-degree Fahrenheit warming to our supply and demand. We found that our supply could decrease by 20%. That's a fifth of our supply lost due to warming alone and no other changes. And we also found that our demand could increase 7%. This means that long-term warming is a significant vulnerability. This simple assessment was informative and proved to be an incredibly valuable mechanism in helping our utility understand and evaluate our vulnerability to climate change. What we learned from 2002 in the Front Range study is that planning for climate change means embracing uncertainty and recognizing we're not able to predict what future conditions will be. To account for these challenges and ensure we are prepared no matter what the future may be, Denver Water has adopted scenario planning, a methodology that systematically develops, evaluates, and prepares a utility for a range of plausible future conditions. We depict the scenario planning process using our cone of uncertainty. Future scenarios are developed based on drivers that are outside of our control, like climate change or economic viability, that will influence future conditions. We then evaluate the implications and supply, demand, treatment, and distribution needs of each of the futures and develop a strategy to meet those needs. Ideally, there are investments that are common across the different strategies that inform near-term investments. And as time goes on, we are then triggered to either reevaluate the futures, start the scenario planning process, or make some sort of investment decision. Even though none of the planning futures will really come to fruition, we are actively preparing for a range of possible conditions and systematically thinking about the assumptions we're making about what the future may be and how our system may handle it. In our application of scenario planning, we are looking at climate change in each of our planning futures, along with changing economics and social values. Our end goal is to prepare for a warmer future, increase our ability to quickly and easily adapt to changing future conditions, and create flexibility we need to recover from extreme events while simultaneously mitigating the consequences of the risks themselves. In practice, that means we're seeking to diversify our portfolio of water system tools, protect and maintain our watersheds and infrastructure, build flexibility and nimbleness into our operational practices and in our building designs, and preserve options so they're available for investment in the future. Let me share a few examples with you now. One way to diversify our system is investing in a variety of new supply, reuse, and conservation options. An example of a new supply project we're investigating is an aquifer storage and recovery pilot we're working on to understand if this option is feasible for our region. Aquifer storage would increase the storage in our system while protecting the supply from increased evaporative losses from warming and wildfire impacts. Diversifying does not only mean having a variety of assets. It also means ensuring our supply is geographically balanced. Our long-range plan identified a storage deficit in the northern portion of our collection system and is addressing this by enlarging our reservoir and raising its dam 131 feet. The additional water storage will help prevent future shortfalls during droughts and help offset an imbalance in our collection system. An example of building flexibility into our system is our decision to modularize a treatment plant we're currently building in the northern service area. Instead of building to the greatest capacity we might ever need in the future, we're building a plant to a smaller capacity with the flexibility to easily expand it in the future if we need to meet greater needs. My final example focuses on watershed protection. Denver Water has spent significant time and money working to prevent wildfire occurrence and mitigate impacts to surrounding streams and reservoirs. This helps contribute to our overall watershed health. Our most notable investment is the From Forests to Faucets partnership with the U.S. Forest Service, Colorado State Forest Service, and Natural Resources Conservation Service. This project stems from the idea that healthy watersheds are so important we consider them part of our water utility infrastructure. In the first 5 years of the partnerships, our From Forests to Faucets program treated more than 48,000 acres to reduce the risk of catastrophic wildfires. The partners will invest an additional $33 million in forest management treatments with the goal of restoring 40,000 acres of overly dense and pest-infested forest lands and continuing reforestation efforts in areas ravaged by wildfire. The value of this investment is already making waves. We experienced one of the many 2018 wildfires happening across the western U.S., and the watershed treatments in that region saved lives, property, ecosystems, and infrastructure. You can see the watershed before, in 2007, after treatment in 2013, and immediately following the recent fire in 2018. As the wildfire hazard worsens in the future due to climate change, investment in watershed health will continue to pay off. In conclusion, climate change is here and now, and climate change is water change. It is our responsibility as water professionals to understand and assess what climate change means to our systems, incorporate climate change into planning and decision-making, plan for multiple futures to ensure we are prepared for whatever the future may be, and seek to diversify our investments and enhance flexibility in our systems. The time to do that is now.